All right, so today we're going to combine two lessons because I think these two naturally go together. The first lesson's real simple, so it doesn't take much time. The second one is way more important. The second one I've seen on a lot of tests over the years. So they typically will ask you this on SATs, ACTs, PSATs. It's just a relationship that you really have to know. So the exterior angle inequality theorem. So let's talk about this. I think we've already talked about this before. What do we know about the relationship between the two remote interiors and the exterior? Do you guys remember that? What's the relationship between these two angles and this angle? These two must add up to that angle, right? And the reason, if you go back in time when you learned this, I don't remember exactly where it was. This angle right here is supplementary to these two, right? And this angle right here is supplementary to it. So they must be equal if they're both supplementary to the same angle. Yeah? All right. And all the triangle exterior angle inequality theorem says is that neither of these is greater than that. That's all it's saying. And that makes sense. If they add up to 180, then each one has to be smaller. Sorry. If they add up to angle 1, then each one must be smaller than angle 1. Pretty simple? All right. I don't use that theorem very often, but there it is. Yeah? All right. And then the angle side relationship is a nice one to know. Okay? And basically all it says, all right, is if a side is longer, so if this side, just by looking at it, yes, if this side is longer than this side, yeah, then that means that this angle is greater than this angle. So that's the side angle relationship. The bigger the side, the bigger the angle. Logical? Yeah? So if you know that this angle is greater than this angle, then you know that this side is greater than that side. All right. That's the angle side relationship, okay? All right, so list these angles in orders from least smallest to largest, yeah? All right, which is the smallest side? RS. So what's the smallest angle? Angle T. Then, well, the second biggest is angles side ST, right? Which would be angle R. And then angle S, right? Pretty simple. All right. What about the angles? If the smallest angle is 20, then what's the smallest side? BC. And then 35 would be AB. And then AC. Pretty simple. Yeah? All right. Easy? All right. The triangle inequality theorem I'm going to spend some time on here. This one we actually end up using a lot. So troll. All right. All right, so say I have 3 sides of a triangle, yeah? I don't know. Let's say these are 3 and 4, yeah? All right, so here's my question. What's the longest this side could be? Math team, you need to be quiet for a while. You need to let them learn about this. What's the longest side? If it's an integral length, right? So an integral means it has to be a whole number, yeah? What's the longest it could be? So 7 is the most common answer, yeah? But if this was 7, yeah? Then what would happen with those two angles? These two sides. If you put them on a like a hinge, like a door hinge, they would come like down there, and they would intersect right here, right? Because this would be 3 and this would be 4. And would it make a triangle? No, in fact, I would say it folds in on itself, right? It would make the line. So what do I know about those two? These two have to be a little bit bigger than that one, right? If this was a little bit less than 7, it would have worked, right? If it was a little bit less than 7, it could be a really thin triangle. So what's the biggest integer length it could be? 6. If this was 6, it would work. But if it was 7, it would fall in on itself. And if it was 8, what would happen at 8? they would never connect, right? The bridge would not happen, right? You'd have 3 and 4, and they wouldn't be able to connect. Yeah? I mean, if you did it down here, that would be 3, and that would be 4, and you'd have this gap of 1. Yeah? So what's the biggest it can be? The biggest it can be, if it's an integer, is 6. Logical? Okay, now here's my second question. What's the smallest it can be? Well, we run into a new problem, and this one takes a little bit more thinking. If this is 3 and this is 4, what's the smallest this could be? Well, you can picture it. This could swing, right? Till it was like over here, like this, more like this. And you're making this, right? Can you see what you're doing? So it'd be more like that, right? So what could this be? 1 is the most common answer. But then you run into the same problem again, right? If this was 1, then 1 plus 3 makes 4. It wouldn't make a triangle. It would just make the side length. So it has to be a little bit bigger, so 2. So it could be any number from what? 2 to what? 6. So you can guess, you can logic your way to the answer, okay? And that is one way to do it. Just logic your way. There's a much better way, okay? Because the triangle inequality theorem, says this: any two sides of a triangle has to be greater than the next side. That's all it's saying. You pick two sides, they have to add up to more than the other side. That's all we're saying. And that makes sense, right? Because if they add up to less, then it doesn't make a triangle. If it adds up to equal, then it falls in on itself. It makes a line. Make sense? All right. So going back to this problem we were messing with, right? How do I do this a different way? Okay, so if I know two sides are 3 and 4, this is what you do. You're going to assume two things. You're going to assume the missing side, let's call it side x. We're going to assume that x is the smallest side. And we're going to assume that x is the biggest side. Okay? If x is the smallest side, what do I know? I know that x plus the next smallest, 3, has to be, so greater than 4. So x plus 3 has to be greater than 4. So what do I get? X is greater than 1. Okay? So you first assume that it's the smallest. Then what do you assume? You assume that it's the biggest. So that would mean that 3 plus 4 has to be greater than the biggest, which we'll now call x. So what is this? 7 is less than x, or a better way to say that, the way we like to have these, we like to have our variable in the middle with our arrows going this way, right? So from here to here, I'll show you two ways you can do this. It starts from 1 and it goes to 7, so it's between 1 and 7. That's one way to do it. Yeah? Another way you can do it is flip this one around, you get 1 is less than x. Flip that one around, you get x is less than 7. And then see how you can smash these together? 1 is less than x is less than 7. But once you know it's between 1 and 7, that's what between means. Now, here's my next question. Is it equal to? No, because if it's equal to, it would not make a triangle. It would fall in on itself. You would not have a bridge. You'd have a road. Yeah? Make sense? All right. All right, so that's all we're going to do here. So let's go back to these. All right. The measure of two sides are 5 and 8. 5 the range for the third side. So remember what we're going to do. We're going to assume that x is the smallest and the largest, yeah? So we're going to do two algebra problems. If it's the smallest, that means the smallest plus the next smallest has to be greater than the longest. So what do I get? I get x is greater than 3. Then what do? I assume that x is the longest side. So I get the smallest, 5, plus the next smallest, 8, is greater than x. So we get what? 13 is greater than x, right? Now there's two ways you can do this. You can flip them both around and change this to 3 is less than x, and then change that one around to x is less than 13, and then you can slam them together. Yeah? And you get what? 3 is less than x is less than 13. Another way you can do it is, you know your arrow is going to be like this, and just write the two numbers, 3 and 13. So So it's between 3 and 13. Including 3 and 13 or not including 3 and 13? No. 3.1 would work, but 3 would not work. Got it? Yep. No, because if it was an integer, yes, but it doesn't have to be an integral length. Yeah? Good question. All right. So here's my first question. You always have to be checking this first. Does it make a triangle? 3, 4, 6. Well, I would say by default, the two smallest has to be greater than the biggest. Is 7 greater than 6? Yes. So, yes, it's a triangle, right? Because 3 plus 4 is greater than 6. That's it. That's the proof. That's the triangle inequality theorem, yeah? All right, let's do B. What does this mean? 6 plus 9 has to be greater than 15. We get 15 is greater than 15. No. And your proof is right there, right? 6 plus 9 is not greater than 15. 888? I always like to do this one. No? You can't make an 888 triangle? Yeah, you can. The two smallest are 8 and 8 is greater than 8. Yeah? Is 8 plus 8 greater than 8? Yes. Equilateral triangles do exist. How about 2, 4, 5? What would you do? Does 2 plus 4 greater than 5? Yes. 4, 8, 16. Because 4 plus 8 is greater than 16? No. It's not greater than 16, right? Got it? All right. All right. Find the range of values for the third side. All right, so what do we do again? We assume it's the smallest. So that would be 1 plus x has to be greater than 6. So x has to be greater than 5. And then what would I do? 1 plus 6 has to be greater than x, which is the longest side, right? So 7 is greater than x. So what is x between? 5 and 7. So if x had to be an integer, what is x? 6. That hard? All right, try B yourself, please. X plus 12. So x is between 6 and 30? Make sure you write it this way at the end, okay? I'm not going to do the rest of those. It's the same process, right? All right, suppose you have 3 different positive integers. So let's call the integers a, b, and c. Yeah? Arranged in order from least to greatest. So you're saying a is smaller than b is smaller than c, right? Yeah, that's what you're saying. So you're saying a, oops, is not greater. A is less than b is less than c. What's one thing I could write to prove that it's sides of a triangle? What's one equation I could write? A plus b has to be greater than c. Easy enough? All right, these are a pain in the butt. All right. Okay, so what are we trying to prove? It's an ugly proof, okay? It's not one of my favorite, okay? But we can work our way through it. This one's not so intuitive. I'm going to walk you through it, okay? Prove that so what are we saying? Prove that AD plus DE is greater than AD minus BE. Okay, let's see. Ready? All right, so we know they're congruent, right? But we're going to do a whole bunch of substitution, right? So AB plus BC is greater than AC. AB plus BC is greater than AC. How do I know that? Triangle inequality theorem, right? Oh no, well that's given, sorry. Given triangle inequality theorem. And that's true for both of them, right? Not that I'm aware of. All right, now what am I doing there? What am I doing here? Subtraction. All right, now what? This one's not so this one's not so obvious. What just happened here? Okay, so we're looking for parts that we know, right? We know that AB plus DE is greater than AB plus DE. This is the one I don't see so obvious. What are we adding to both sides? I don't see it. Am I adding these two together? Oh, okay, that makes sense. But that would have taken me a while. Yeah? So we're adding them together. So that's actually substitute. If you call that addition, no, let's just call it addition. If you call, I probably want to count off if you call that substitution. Okay, now what happened? We're rearranging it, right? Why are we allowed to rearrange it? You know, remember this from, it's an old property. If you're adding multiple things, you can change the order that you're adding them in. Commutative property. Yeah? All right. And then see how we're factoring out the -1? This would not be intuitive, right? I told you this wasn't going to be. We factor out the -1, right? You can say simplify there. I'm not really sure what you would call that. I think that's probably simplify. Now, why is AC plus CD equal to AD? Nope. Segment addition. And you see what we're going to do here? By setting up segment addition, look here. We have AC plus CD, that's this, right? And we have BC plus EC, that's this. So now what are we going to do? Plug that in for that, plug that in for that, and you get that it's true, right? So what is this? Substitution. All right? Not a pretty proof, yeah? All right, let's try it again. This one's a little bit easier. What are we given? That PL is parallel to MT. All right, so let's just work our way through it without doing a proof. What else? K is the midpoint of PT. So that means that this is equal to this, right? What are we trying to prove? That PK plus KM is greater than PL. PK plus KM is greater than PL. All right. First thing I would do is prove that these, if they're parallel, then this angle's, let's think this through. If they're parallel, then this angle is equal to this angle, right? And I believe this angle is equal to this angle, right? Which proves what? The triangles are congruent. And then I can probably do something from there, right? What am I trying to prove? I'm trying to prove that, let me draw it here. I'm trying to prove that this plus this is greater than this, yes? Yeah? Well, check this out. I can prove that Km is going to be equal to LK, right? Because I'm going to prove these triangles are congruent. So then I could substitute in that for that. And I already know that these two sides, let me change my color here. I know that this side and this side add up to more than that side by the triangle inequality theorem. So all I had to do is figure out a way to substitute that in, and I can say that that's equal too. So it's not going to be that hard. This was given, right? Angle P is equal to T. What is this? Alt interior of parallel lines, right? You don't have to write parallel lines if you don't. K is a midpoint given, so PK is equal to KT. Definition of midpoint. They did vertical angles, right? So what is that? So that's PKL is congruent to TKM, right? By vertical angles, which proves that triangles are congruent by, you got to be careful now. Angle, angle, side, right? No, it's not angle, side, angle. You got to be careful. No, not in this case. Not if we use vertical angles, because look what we just did. We're saying that, remember, we're saying that this angle is equal to that angle, this side's equal to that side, and we just proved that those angles are equal, right? Okay. Did we say P and T? Oh, okay. All right. If we had picked the bottom, we would have said angle, angle, side, right? We picked that one, so that is angle, side, angle. Okay, so ASA, right? Triangle inequality theorem says what? That PK plus KM is greater than what? PK plus, oh no, PK plus, sorry, PL, LK, right? PK plus LK is greater than what? PL. That's the triangle inequality theorem, yeah? Now what am I going to use here? What do I need to substitute? I need to substitute Km for LK, right? So what do I prove here? LK is congruent to Km, right? Actually, I can just write it this way. Just write it this way. LK is equal to Km, right? By CP/CTC, yeah? Thus, PK plus Km is greater than PL by substitution. All right, I'm not so worried about these proofs, but I will tell you, you better put this stuff from here in your long-term memory. Does it how to tell if something makes a triangle, and what is the what are the values that it could possibly be? Yeah? All right.